Good evening, everyone. Welcome to Kopernik Observatory and Science Center. Welcome for our in-person audience here and also to our live stream viewers. We're streaming this program tonight. We can talk a little bit about that and how you can tune in to our virtual events as well if you can't make it up to the observatory. First, let me just see a show of hands if this is your first time at Kopernik. Oh, got a few over here. Okay, perfect. So, if you're new to Kopernik, we're open every Friday night like this until mid-December, where we do close down a little bit. But so from now through spring, summer, and into fall, we're open. And best thing to do too, if you're interested in checking out our telescopes and looking through them, because I don't think the skies are quite going to behave for us tonight, you can click down at the bottom of our website. This is Kopernik.org. You can click the clear sky chart, and this will give you a astronomical view of the weather forecast. Actually, let me flip the light switch here too. There we go. Now it should be a little more visible. So if we look here, the top row is cloud cover. And what you want to see is a dark blue, ideally. We'll take a light blue too, in worst case. But tonight, it's not looking super promising. When it's a white block, that means just about 100% cloud cover. So this is something to keep in mind for future Friday nights. But of course, we're always open regardless for programs like this. And you can always return to that. Okay, so Kopernik.org has all the information about our upcoming events. We have some big ones like beyond the Eclipse events, of course. We have Race to the Stars coming up on April 27th. So if you're a runner or you know a runner, let them know about Race to the Stars. But our immediate interest is this tab here, which is March to the Eclipse. We will continue marching to the eclipse next week when it turns to April. It'll work well enough. So, March to the eclipse, we've been running eclipse programs throughout this month, covering what the science of the solar eclipse, what you can expect. We've had some family Fridays as well, where we had families come up and try go through some activities to better understand the eclipse, and we had some planetarium shows too. So this is our event schedule. You can find it here. Whenever there is a presentation like this one, we do post them on this webpage on YouTube, or you can just visit our YouTube channel. So you can see if on March 15th we had the Great Adirondack Eclipse presented by Seth McGowan. So you can just click on this link and it brings you right to the eclipse program. So that's there for you. Then this is the second to last solar eclipse presentation. We're wrapping up our March to the eclipse. So Eclipse Among Spring Skies tonight, it's kind of a mix of information about the eclipse plus what's out in the spring skies this time of year. And then next week is our final total solar eclipse outlook. So across the state, across the region, what are your best chances for viewing the total solar eclipse? And what is Kopernik doing on April 8th if you don't want to drive out to the total eclipse? Because here we'll have a 97% partial eclipse at Kopernik. And that brings us to the partial solar eclipse observing session on April 8th from 1 to 5 p.m. and the total solar eclipse observing live stream, because our eclipse science team will be traveling to Totality on April 8th, and a part of that will be streaming out a live view of the total eclipse to our YouTube channel viewers. So you can always tune in there. We'll have it running on site at Kopernik as well. So if you're viewing the eclipse here, you'll see us there. Okay, so that's the eclipse. If you still need eclipse glasses, they are available in our gift shop. There's the countdown to the solar eclipse in 9 days. Very exciting. And we do have a solar eclipse related class as well for grades 3-5 and grades 6 through 8. So this is running on Thursday next week, and we still have slots available for I think the 6-8. There might even be one slot for the 3-5 too. So if you know anyone that would like to participate there, that is available as well. For now though, let's jump into our presentation, which is the eclipse amongst spring skies. So this is a little preview of at least what we'll talk about as it relates to the eclipse itself, because if you're able to go and travel to totality, it's going to get dark enough in the sky that you'll be able to look for some things out there beyond just the eclipse. Now, I want to emphasize the total eclipse is what you want to see, because that's super, that can be rare for a given locality. So the next time that a solar eclipse happens for our area, in fact, yeah, the best one will be in 2079, which is when it actually passes through Kopernik. There's totality over Kopernik in 2079, which is pretty incredible. But it misses us this time. 2045 is the next time it goes, an eclipse goes through the United States across a major portion of it. But totality is not as close to us that time as it is this time or in 2079. So we'll talk about the eclipse, but we'll also talk about the night sky in the spring too. So yeah, we're discussing the International Space Station, the ABCs of stargazing. We always like to touch on that. So just giving you a framework to work within to understand how to navigate the night sky and the daytime sky. Then what can we see in the sky? We're going to emphasize the April 8th solar eclipse. We're going to talk about solar system objects, deep sky objects, and then finally some observing tools you can use that you may already have, and you may already own, or at least are very accessible. So I also forgot to introduce myself. My name's Jenny Cartie. I am a science educator here at Kopernik Observatory, so I'll be leading this program tonight. All right, there's a reason I'm starting us off just like almost randomly, or seemingly randomly, with the International Space Station. Okay. So let's talk about the ISS first, and then you'll see why. We're getting into it right away. So that's the ISS in orbit around Earth. It's a real image. The station itself is the size of a football field. And the astronauts live within this section, the central structure. So it's kind of face on, so you're not seeing the entire thing. You'd have to look at it from another angle to see it's a long corridor of capsules and tube structures. This structure here is not livable. That's the solar array and support system. There's also radiators here. Those aren't solar panels. Those white sections, those are radiators to dissipate heat from the station. So, and then these big things are the panels that power it. So, the space station orbits 250 miles above our planet, and it orbits once every 90 minutes. So it's zooming around Earth. They get to see, at least in one circular round, they get to see all of that path of Earth in 90 minutes. And that's moving at 17,500 miles per hour. Sounds fast, but just how fast? At that speed, you could travel from New York City to Los Angeles in 9 minutes. So it's booking it around Earth. And what's neat is if the skies are clear, see how we're doing on time, not bad, there is a flyover in the next few minutes. So we will double check to see if any clearing happened. We don't need too much, even if it's just partly cloudy, we'll see it move through the gaps in the clouds. So that flyover tonight is at 8:18 p.m., coming up very soon. It'll start in the northwest at an altitude of 10 degrees. You can see it going down that column. The highest point is at 8:21. It's actually a pretty significant flyover at 59 degrees in the north-northeast, and then at 8:24 in the east-southeast, an 18-degree end time. That's when it will move into darkness, so there won't be any sunlight there. It's moving across the terminator and into the Earth's shadow. Okay, so there's tonight's. You also have another one tonight. So if it clears up again after the program and we're still here, 9:55 p.m. start for that one. It's pretty short, though, because the Earth's shadow will have shifted enough where it's going to enter the shadow much quicker. And so you can see the highest point is also its end. Okay, and then there's my alarm for checking the skies. Then March 30th, that's a start time of 9:07 p.m., west-northwest, altitude of 10 degrees. Highest point is at 9:10. Not as significant of a flyover, but even after the highest point, you do have a little bit of time after, just about a minute, as it drifts down to 25 degrees and disappears. So, who's on board the ISS? Well, there's this website you can visit called whoisinspace.com. Pretty convenient. So let's jump to that quick and find out who's in space. It gives you, right off the bat, there are 13 humans in space. Now, 3 of those are not on board the ISS. The other 10 are. The other 3 are on board the Chinese space station. So 13 humans in space right now. Let's go through the list. It gives you a nice overview, too, of how long they've been in space. So I'm going to do my best with some of the names here. But those that flew aboard the Soyuz MS-24, we have Oleg Kononenko, and that he is currently the record holder for time in space. And he's not done yet. He's going to be up there even beyond 1,000 days in space. So he just recently, I think around 850 days, he passed and beat the record. A previous cosmonaut held that record. So 933 days in space at the moment. Then Nikolai Chub, another cosmonaut. Most of for the Soyuz, those launch in Russia. So you'll often find cosmonauts fly aboard these rockets. But there was a NASA astronaut as well, Laurel O'Hara. Then this is very cool because, and actually I just got to double check the time. Drew, do you know is it clear at all, or?
It wasn't, but let me check.
Okay, just take a look. Yeah.
Nope.
No, all overcast. Oh well, but that's okay. Maybe we can check again and see if anything clears up, or there's the opportunity tomorrow as well. I'll show you the website too that you can visit to see future flyovers, now that we have some time to spare. So for SpaceX Crew 8 that just launched on March 4th, we have 4 astronauts. We have Matthew Dominic, Michael Barrett, Jeanette Epps, and Alexander Grebenkin. So 3 NASA astronauts from the US and 1 cosmonaut. So Jeanette Epps grew up in Syracuse. So she's a semi-local astronaut, at least a regional astronaut. And so she flew up on SpaceX Crew 8. It is also her first mission to space. Later on, after the program, you can venture out into our lobby. If you saw the mural, the big picture of the space shuttle, that's our Astronaut Hall of Fame, or Wall of Fame, I guess. And you will see her signature on that wall, because she visited in 2014 as she wrapped up her astronaut training. So, yeah, we're very neat that we have a regional astronaut in space. Okay, and then scrolling down some more, there's this ISS Soyuz MS-25, and we have 3 more astronauts here. So Oleg Novitsky, Tracy E. Caldwell-Dyson, and Marina Vasilevskaya, something like that. So those are the 10 that are on the ISS. And then this is the Tiangong space station, the Chinese space station. The 3 astronauts on board that one. So 13 people in space and 10 that would have flown over us. Well, they are, regardless, flying over us. We just can't see it. When you do see the space station fly over, it looks like a very bright point of light in the sky, kind of like a moving star. No blinking lights. So that's one way to distinguish satellites from airplanes. Airplanes will always blink. Satellites like the ISS won't. There'll be steady lights because it's all solar reflection. It's no artificial lighting that's generating that point in the sky. So let me go back in the slides here for a sec. Did I have that? Yeah, this one. So you may, this is a free way to look up ISS flyovers if you go to heavensabove.com. And it breaks. We'll just search heavensabove.com. There we go. So this website, if your GPS is set up on your computer, it'll find your location, or you could just search for it. And then you can come down to, if I can click on it, ISS. And that is the upcoming flyovers. So you can see it goes from the 29th to the 2nd of April. You can do visible only, or you can see all of them. This will show you even the ones that the ISS is flying over, but you won't see it in the sky. So really, this is the most valuable when you do visible only. And you can skip ahead through time as well. So you can even see ones in the future. The further out you go, the trajectories become less accurate because the space station will make adjustments, but you'd usually have to go several months in the future to notice a significant change. So it's pretty accurate. Okay. So we'll jump back here. That's the ISS. And we went to who is on board, so we'll pick up there. And there'll be plenty of more opportunities too. Even when we don't have presentations like this and the ISS is flying over, we usually try and find a way to, if it's in the middle of a presentation, bring people out there. And if it's any time before or after, we highlight that as a major event. Okay, so now we're going to build that framework for understanding how to navigate the skies. And if you've seen one of our skies presentations in the past, I'm sure you're super familiar with this at this point, but we'll review as well. So ABCs, we're going, A is for angular size and distance. And with this one, this diagram shows you your best friend when measuring the distance between objects, even the size of objects in the sky, is your hand. So it gives you a nice diagram. We're measuring angular distance, so it's measured in degrees. So if we look at this diagram, your pinky, the width of your pinky, this is all stretched out at arm's length like this. So you could practice if you want. So if you're looking up at the real sky, arms stretched out and your pinky's out, the width of your pinky is 1 degree in the sky. So another, if we want to relate it to the eclipse, your pinky nail is maybe around 1/2 degree, which stretched out, that would be about the size of the moon and the sun in the sky. They're about the same size, and that's what drives our total solar eclipse. The total solar eclipse is when the moon fully covers the sun, blocks out all of that light, and it's all driven by the fact that they're roughly the same size in the sky. Not if you were to measure them directly side by side. That's all perspective at work there. Okay, then you can do 3 fingers out, arms stretched out, and that's 5 degrees across. If you make a fist, that is 10 degrees across. Index finger and pinky spread out a little bit, that is 15 degrees across. So it's a really handy trick to measure objects in the sky. Here's a nice diagram of the Big Dipper. You could test this out. Big Dipper is frequently visible to us in our northern skies here. So you could measure the entire width at 25 degrees, star to star there, 15, 10 degrees, 5 degrees. It's good practice to just use a bright constellation like that and build an understanding of how your handy tool works. Okay, B is for brightness. And in astronomy, we call a measurement of brightness for objects magnitude. And there's different types. There's apparent magnitude. There's apparent magnitude, and there's absolute magnitude. Absolute magnitude is if you were able to take all these objects in the sky, collect them all, put them all in the same lab, and study their brightness right there. But of course, that's not how our skies work. Distance is at play, and that means we have to measure apparent magnitude. So how do they appear in the sky? How does their brightness compare? So that's our magnitude. And here's a diagram to show you how astronomers measure magnitude. So it's a line diagram. You can see positive numbers on this side, negative numbers on that side. And notice the sun is on the left. That may seem counterintuitive, and that's not your fault at all. It is counterintuitive. So brighter objects are going to be, the brightest objects are going to be negative numbers on our magnitude scale in astronomy. Positive numbers are dimmer objects. So going through, the sun is out there past negative 25, around negative 30. The full moon, around negative 13 in magnitude. Jupiter is around negative 3. Then you get a bright star like Vega, one of the brighter stars in the sky. That's right at the 0 marker. Andromeda galaxy, that is around a 4. The faintest naked eye objects that your eye will pick up are around 6. So that's what your eyes can see in the sky, is around a magnitude of 6 on a moonless night. So you can see the Andromeda galaxy with your eye, which is pretty awesome. And then out here we have something fainter than your eye can see, which would be the Ring Nebula. And then beyond that, it's all sorts of deep sky objects out there that our eyes can't detect. But telescopes and binoculars and optical equipment, cameras, and so forth, they can. So the reason why this is counterintuitive, early on in astronomy is one of the oldest sciences. And early on, they would measure the brightness of stars, kind of ranking them. So your magnitude 1 stars would be brighter. It's almost like first, second, third place, and so on. Your magnitude 2 stars, dimmer, and so on. And just the way astronomy played out over the years, it just took on, even when they were actually able to measure brightness. So they had to modify the original idea of first, second, third magnitude stars and adapt it to how we can actually measure brightness. And that's why it ended up this way, which is very confusing. But that is how we measure magnitude in the sky. And we'll come to measuring magnitude with some of the objects we'll observe using an app called Stellarium. We can actually look at the absolute and apparent magnitude. Okay, C is for coordinates. And we'll look at 2 different coordinate systems. First, altitude azimuth. Altitude azimuth coordinates are when we can really easily use our handy tool to measure degrees in the sky. It is a coordinate sphere around you, but what's nice about it is that it's with respect to you at your location. So you're an observer looking out in the sky, and you're looking at, let's just say, the moon in the sky at a certain time. In that moment, when you first point to it, it has specific altitude and azimuth coordinates. But in the next moment, it's changed significantly. It will have a different set because this system is with respect to you observing out in the sky. It's not keeping up with the objects themselves. So there's no specific coordinate for something like Vega in the sky, something like the sun in the sky. It's going to change. Okay, so that one's simpler though, because if you just look at the degree measurements around the horizon, your north is 0 degrees. I should be pointing with this too, so the live stream can see. North is 0 degrees. And then you come around to the east, which is 90. Then to the southern part of the sky, that's 180. Western is 270. And then you come back to 360, which is your 0 marker again. So that's around you based on the compass directions. And then you have altitude, and altitude's easy. So you can just measure up to the very highest point in the sky, that's your 90-degree marker, and anything in between is 0 to 90. And that would be for anything in altitude around you. So they give you the example of this star in the sky. Its altitude is 50 degrees up. You can see it's past the halfway marker, so around 50 degrees. And then the azimuth is 150, so before the southern 180. Okay, so that's one coordinate system. The other one, and this is what a lot of telescopes, especially tracking telescopes, use, is equatorial. And this is if we mapped out the celestial sphere around us of stars that we see across our planet. We mapped out a coordinate system that is specific to the stars that are there. So stars like, it's going to be hard to pick one out here with the constellations. But at a given, in a longer range of time, the sun is going to have specific equatorial coordinates. So, and then the stars in the background, like Vega we talked about earlier, they'll map onto the sphere that you're seeing around Earth, and they will have specific markers. You can see this is the celestial equator. That's as if you took the Earth's equator and expanded it out into space. This green line, the ecliptic, is the path of the sun throughout the year. And going back to the red line, the equator, that we mark out in hours and then in smaller units, minutes. That's our right ascension. And then we have declination, which is similar to altitude, and that's degrees. So mostly those coordinate systems I'm showing you. So if you continue to explore astronomy, you can refamiliarize yourself with these, just to make you aware this is how astronomers map out the sky. Okay, let's have a quick look in this app called Stellarium, because we're going to use this throughout the show. And this is what it looks like. So let's get rid of that. I'm also going to turn the atmosphere back on. So there's all sorts of tools that you have available to you in Stellarium. This is the downloadable version, in this case for Mac, but you can also download it for Windows or Linux. There's smartphone apps for Stellarium, and there's a web-based version too if you just want to run it through a web browser. So we're using the downloaded version. And this is your at-home planetarium that runs on any screen pretty much. So I'm clicking and dragging to change my view. This is equivalent to just turning your body or turning your head to look at a different point in the sky. So we're clicking and changing our perspective. Now right now I have the constellation lines up in the sky mapping out and helping us navigate where we are. I can turn those off too, so we just have the brighter stars and objects in the sky. Or I can turn them back on and add the labels so I know which constellation is which.
Like the trees and the lights, are they comparable to what is around you?
No, in this case it's just a default setting. But there are ways that you can map in your own picture, your own imagery as a landscape. So then you can add artwork, and then you can see a little bit of mythology. What's cool about Stellarium as well, and I think it's the sky and viewing options, yeah. You can go into star lore. In astronomy, generally the star lore that's used is Western culture, so generally Greek and Roman. But you can go through any of these star lore cultures and see how different cultures throughout our history have looked at the skies different. What pictures did they see versus another culture? It's pretty neat that you can do that. But when we navigate in astronomy, generally it's the Western constellations that are used, again, just by convention. Okay, so there's our constellations. Like I mentioned earlier, I can turn off the atmosphere, which is going to get rid of some sky glow. You can see a lot more stars come out when you turn off the atmosphere. It's not realistic to do that, because then we can't breathe. And you can't be impossible to. But it is a nice option for looking a little bit deeper than what your eyes could see when it's simulating that with the atmosphere on. You can also turn off the ground. That's handy to see what's below us, what might be rising, or objects that we can't see at all that would only be visible in the southern hemisphere. Turn the ground back on so we have somewhere to stand. Then we have deep sky objects. We might check those out a little bit later. So those are objects like nebulae, galaxies, star clusters, things beyond our solar system, but more than stars. Okay. And then, of course, you have ways to adjust time, because this is a time machine. So you can time travel using the media bar. That's not as specific. If it's just you want to see how the sky changes through the hours quickly, you can do that. You can see how the sky spins. And it's all spinning around the North Star for us. So if we go to the northern sky, there it is. That's the North Star, and you can see the entire sky spins around it. If we bring up the coordinate systems too, I'm going to turn the atmosphere off so the sun doesn't brighten the sky. If I bring up the coordinates, I can bring up that azimuthal grid. Notice the sky is rotating, but the grid is staying there. It's fixed to your observing location. But if I turn the equatorial grid on instead, notice it moves with the stars. So that's the power of the equatorial grid, is it maps things out in the sky. Whereas this is better for just a momentary, that's where that is right now. Okay, let's return to current time. I'm going to hit the play button, and this little hourglass shape returns you to present. There's another clock window here, date and time window, that's on the left toolbar, and that lets you specify date and time. We will use that a little later, but that's a nice overview of Stellarium for now. Satellites show up in here too, so the accuracy is kind of hit or miss sometimes, but out of curiosity, before we exit Stellarium for now, let's back up the clock to when the ISS was flying over. Oh, I think that was it. Right there. So Stellarium will also show you satellite flyovers. It doesn't give you a complete overview of like it did in Heavens Above, but if you're just checking out what's available in the sky in that one night, you'll see things like the ISS fly over. And that's actually a good approximation of what it looks like in the sky. Little star, but it's actually the human-made ISS. Okay. can't see it in the real sky, you saw it here. Go back to present, and we'll return to this a little later. I'll leave this slide up for just another second here in case you want to record. It's just stellar EM. Think of like planetarium. Okay. So let's now discuss what we can see in our spring skies, both day and night. Starting with the solar system. And of course, in almost a week from this Monday, we're going to be very focused on the solar eclipse and the sun. So our sun, pretty average star out there in the universe. It's categorized as a yellow dwarf. That's a little misleading, though. It's actually, if you could get away from Earth, if you could fly out in space, like the astronauts on the ISS, the sun is actually white in color. That yellow color only comes from light being filtered through our atmosphere. Now, if you look at this image here, that is certainly not yellow or white. There might be some yellow tones in here, but that is driven by the filter that was used to capture that image. So notice down here, this word of caution. We're going to talk more about safety as we discuss the eclipse, but do not view the sun without the right equipment. So if you have a telescope or binoculars at home, it's the only object off limits in the sky to you. Unless you know exactly what you're doing and you have the right filter and you've done your research. At places like Kopernik, we have all of that equipment to make solar observing safe. So this was taken through one of our telescopes called a C-Star S50. Brilliant little telescope. Great for solar observing. And it has a filter that you attach so that you can remove almost all of the sun's light, over 90% of it. And it's safe for the optics in that scope. So this is what the sun looked like just a few days ago. I think it was Monday or Tuesday. And you see all these speckling spots across it. Those are called sunspots. Makes sense? And they vary in size. They're magnetic storms on the sun. Very different from the storms we have here on Earth. We don't really have magnetic storms, but it's space weather, it's solar weather all the same. And they, like I said, vary in size. This one, maybe right here. That one is about the size of Earth. Give you a sense of size. You can fit 100 Earths across the sun. So from here all the way over to here, you can fit 100 Earths. So this system right here, when we first saw that, that actually surprised me. Because at least it's been a while since I've observed the sun during this period, solar maximum. The solar cycle plays out over 11 years. So every 11 years, you get this maximum period where the sun is very active. What it's doing, the reason why it's active is because it's about to flip its magnetic poles. That happens every 11 years. And when that happens, or just before that happens, the magnetic fields of the sun start tangling and interweaving. It's becoming very chaotic during that time. So you're not just getting a basic north and south pole on the sun anymore. You're getting all sorts of north and south poles all over the sun, all mixed up. And this is evidence for that. Because or any sunspot, but this one in particular, this crazy cluster, all mixed up. You have north and south poles all over the place in there, and it's disturbing the surface of the sun, creating these storms, these sunspots. So that particular cluster is pretty incredible, because usually there's some organization to this chaos in that a lot of sunspots come in pairs. So you can see this one. There's a pair up here, pairs here. This one probably has a smaller pair nearby. But as the sun becomes more chaotic, all these fields mixing, you even start to lose that consistency. So that's pretty neat that we have this solar maximum in the same year as a solar eclipse, because it means that we get to see not only the eclipse itself, but a lot of activity on the sun, if you're observing safely. So there is a total solar eclipse on April 8th. Let's narrow in on eclipses for a moment. Well, longer than a moment. So the types of eclipses, of solar eclipses, we have total eclipse, we have annular eclipse, and we have partial eclipse. On April 8th, we will be seeing two of these three. We'll see a partial, and if you travel, you'll also see a total.
Which part of the US
Yeah, I'll show you some of those on the map and some resources you can use to explore. So this one, the annular eclipse, happened at some locations on October 14th of last year. The Ring of Fire eclipse. But we won't see that. That happens when the moon is too small in the sky and it's not able to fully cover up the sun. So these are very similar, these two events, but it's the difference of the moon being bigger than the sun or smaller than the sun in the sky. Then over here is the partial, and we'll see what our partial eclipse looks like for our location in Vestal. We're only getting a partial here. It's a very deep partial. Up in Syracuse or beyond, in Rochester, Buffalo, Watertown, those are where you'll see the total eclipse for a couple minutes. And here's a map of the total solar eclipse and partial eclipses. You can search for this just by looking up Solar Eclipse 2024 NASA map. It's a great one. It's very high resolution, and you can see the layout of the partial eclipses. These are the gray lines stretching across the states. And if you may, at least those in the front, may just be able to see these little percentages that line up with those gray lines. But what's most interesting on this map is the path of the total solar eclipse. That's the dark band across the image. We can even model this. This is the path over time. But if we're modeling an instant of the path of totality, then we can pretend our projector up here is the sun, this is the moon, and the image up on the screen is the surface of Earth. So here's where the shadow begins in Mexico, down here. Actually, I got to get a little bit closer and try and fit it in that path. And then it stretches up through Texas, through the states. The shadow of totality is circular like this, but it also blends with the partial eclipse too, so it ends up looking a little fuzzy around it as well. Just like if you look around the room at shadows, you see a very dark part of the shadow. That's what we're seeing here. But you also get the fuzziness around it as well for partials. Then it goes up along the path, and right in here is our area of interest. I'll point out Binghamton. We are here, just above the arrow. So we do not get the total solar eclipse. We get very close. If you want to see totality, nearest city is Syracuse. The further north in Syracuse you go, the better chance you have of observing totality, especially if it's cloudy that day in any way. So yeah, we'll take a look at that. And with timing, I have a great website to explore. So yeah, that is right there. That's Syracuse. Over here is Rochester, which is even more towards the center. The closer to the center of this path that you get, the longer the total eclipse lasts. So the difference between Syracuse and Rochester or Buffalo that are closer to center is about 1.5 minutes. That may not sound like a lot. You're going from like 2 minutes to 3.5 minutes, maybe a touch more. It's pretty significant when you're dealing with any sort of weather that day, though. So if you can travel further, or if you already have a place planned out closer to centerline, you're in good shape. Plan to stick around in that location. But regardless, even if you just want to try to get into Syracuse and see totality, that's a good option too. I will mention as well, out here in the Adirondacks, we just had our presentation on the 15th about their event. So if you really want to get adventurous, there is a great event planned by the Adirondack Sky Center at Tupper Lake, and they're in the path of totality. So you can go watch that presentation on our channel too if you want to learn more about what they're doing. Okay, so there's the path of totality. Let's check out this website, timeanddate.com/eclipse. This is your tool to narrow down the different locations, the exact timelines for this event. So if we click on Total Solar Eclipse, April 8th, we can search for a city. Let's start with Vestal. Now I will say, not to be too critical of Time and Date, but their search is sometimes terrible. So Vestal sometimes pops up like way down here for some reason. It really doesn't, it's not connected to your GPS in any way in your computer, so you'll just have to do a little look through, make sure it says New York. Click New York. And you'll have to go down again, and you'll see all the eclipses coming up. Click April 8th. And this gives you an overview. So the global event is a total solar eclipse, but the local type is partial. It begins on April 8th at 2:08 p.m. Maximum occurs at 97% at 3:23 p.m. So a 97% maximum, 3:23, and ends at 4:34 p.m. This will let you play a preview of the eclipse much faster than real time, because you saw before in those times it's 2.5 hours. You can watch the path of the moon across the sun, and you can see why we're upset, because we don't quite get that total eclipse. We just get that very, very thin crescent, which is not safe to look at with just your eyes. That's still direct sunlight, and you can damage your eyes. I just came across a post that was a retinal scan of someone that looked at the eclipse event, and there was a clear damage to their retina. This was back probably in 2017, maybe before that, but that's long-term damage, and it's permanent damage if you stare at the sun in general for a long time, but during an interesting event like the eclipse, it's even more tempting. So we'll talk about safety in a minute, but I can't stress that enough. Do not stare at the partial eclipse with just your eyes. So then we have the eclipse end, and before and after, just a regular sunny day. Hopefully. We really hope.
There was a little voice that asked, what can you use to look at that?
Oh, the sun. We'll talk about it. Yep, we'll talk about solar safety in just a minute. So, yeah, there's the eclipse preview for our area. Now let's just jump up into Syracuse. And again, the further north Syracuse you go, the better. So we're going to go to North Syracuse and click April 8th. And here you can see the global event, total solar eclipse, and local type is a total solar eclipse. If you get deep into North Syracuse, you get 2 minutes and 3 seconds of totality. Just over 2 minutes. It begins, the partial eclipse begins at 2:09 p.m. Maximum totality is at 3:23, and eclipse ends at 4:34. Similar timing, but there's also these extra steps in the layout. So first, as we play through, here's the start of the eclipse at 2:09 p.m. 2:09 p.m. is start. Totality happens at 3:22 p.m. Then maximum is at 3:23 p.m. That's the maximum stage of totality. It's when you'll experience the darkest sky. You'll kind of be in this, at least of the local center of that eclipse stage. And then we go to totality end. Very quick. This tiny little section on the bar is what the total eclipse is at 3:24 p.m. And then it'll play through the partial eclipse. And that ends at 4:34, just like here. So you could bounce around to Rochester and Watertown and all sorts of places to see how this changes and how maximum changes as well. You can also click on the detailed eclipse path and see that similar layout. And you can click around here too and just get a very nice view of how things change and bounce around New York to see what your options are for travel. And it gives you your summary here. Okay, so that's a little overview there. Let's jump back.
What was that website?
That is, I'll bring it up right here. Yep. This is the website you can go to. And you just got to make sure you put in your specific location or just bounce around that eclipse map like I just showed you. So I'll leave that up for another moment. Of course, with the eclipse, I will say a couple things with, I don't have it in my safety talk, so I'll say it here. Traveling to totality is worth it if you're willing to brave the roads. It's going to be pretty much, no matter back roads, main roads, highways or otherwise, it's going to be crazy that day. Going there and coming back. So if you're doing a one-day trip, make sure you have some gear, food, any sort of basic survival equipment in your car, because and make sure you maybe even things like making sure your gas tank is full, because those are things to be concerned about, being stuck on highways and so forth on that day.
And a box full of patience.
And a box full of patience, yes. So it is worth it, though. Think about it like this: if you're willing to brave all that, it's just one day, and if it means you get out to totality, it's so close and accessible to us. You'd have to pay thousands of dollars to travel somewhere to see a total solar eclipse in the near future. This one's right in our state. So, if you're staying there, right? That's a difference. Is if you're staying overnight, certainly that's going to be pricey. But if you're just traveling, just out to totality that day, it's much more cost effective. So it is a big difference. So yeah, that's that website there. The Eclipse in Stellarium, I'll briefly show you that, just to show you the power of Stellarium as a tool. And let's go to April 8th. You bring up that clock window there, and we're going to bounce the hours back. This is the eclipse for our area. We're not going to do location jumping in this. You can do that in time and date. You can do that in Stellarium by going to the location window. So that's just a little more in depth for you. But we'll zoom in on the sun. Now in the real sky, at this stage, this is at 1:56 p.m. on April 8th, you are not going to see the moon in the sky like that. In fact, if I bring the atmosphere back on, even that is not accurate. The reason Stellarium's doing that is just to give you some guidance as to where those two objects are with respect to each other at that time. But if we click the minutes forward, you can see the moon starting to pass in front of the sun. And you keep going. That started at 4:08 p.m. for us. Maximum eclipse at 3:23 p.m. Did I say 4:00? Yeah, 2:08 p.m. Yeah, 14. I keep doing that. I don't know why. And at 4:34 p.m., eclipse wraps up. So 2:08 p.m. start, 3:23 maximum, 4:34 is your end. So let's jump back in here. All right, solar eclipse safety. This part's super important. Your best friend during the eclipse event, whether you're visiting totality or not, eclipse glasses. We do have some. Available in our gift shop. The filters are the ISO certification safe, so they'll protect your eyes during the eclipse event. I'll show you a pair here. These were the NASA ones from 2017 that we used. And this is what they look like. Very important, there's two sides to these glasses. There's one side that is glossy and shiny and almost has a silver look to it. The opposite side is black in color. So you want the glossy, shiny silver side out, and you want the black side here against your eyes. So keep that in mind with our glasses too. The ones available in the store are all white on the front, and on the back you have your instructions. So those instructions go on the inside. The way you use these is you face your back to the sun. You never want to stare at the sun directly with just your eyes. So back to the sun. You put the glasses on, glasses wearers, try and fit them over your glasses. And once you're done, you can turn around, and here's our sun. We can look at it for as long as we want. Even a regular sunny day, these are fine. The only thing you have to worry about long term is looking for holes, scratches, things like that will damage the filters themselves. For the eclipse, in the case of our eclipse glasses in the store, we have envelopes that are included with the glasses that have instructions for safe use, and you store the glasses in there to protect the filters. Once you're done observing, you turn back around, back to the sun, glasses off. No more staring.
10 seconds? How long you can see?
Oh, you can look for as long as you want.
Oh, okay.
Yep, there's no time limit with these filters. Yep. So that's eclipse glasses. Oh, actually, I can demonstrate one more thing for you with these two. Flashlight on my phone, pretty bright. Disappears. That shows you how strong these filters are. They're removing over 90% of the visible light so that it's safe for direct viewing the sun. It also absorbs and reflects all of the harmful rays, like ultraviolet. Ultraviolet can have severe damage on your eyes, can cause severe damage. So these filters are designed to protect against that.
You can look at the sky even normal days, right? Even normal days.
Even normal sunny days, you can put these on and stare at the sun. Yep, just make sure that over time these lenses do not get scratches or punctures, because if they do, then they're done. So keep them inside your envelopes or any sort of protective sleeve leading up to the eclipse, even a glasses case. Now this one, back in 2017, we had someone, maybe even properly, put on a pair of eclipse glasses facing their back to the sun. Do not recommend using any sort of reflection during the solar eclipse. The safe ways that I discuss here today are kind of the ways to safely observe. Okay, so yeah, I should put this on pause so that we can enjoy we see how quickly it all happens. So let's pause the eclipse here. So that's the solar corona. That's the focus. If you get to totality, watch the corona. This is what makes the total solar eclipse, it's arguable how many times better, but just kind of arbitrary, 100 times better than a partial eclipse. But what you can also see, if you're traveling to Rochester a longer time period, you get those 3.5 minutes or more, look around the eclipse, because you'll see things like bright stars and bright planets out in the sky. This is doing a decent job of showing you what will be visible. I'm going to turn off the constellation lines right now. And if we pan around the sky, you'll see there are some planets out there around the sun and around the moon. Pan to the other side of the sky, not too much out there. There are going to be some brighter stars, like maybe Arcturus will pop out, maybe Vega, and Sirius too if it's up, though I don't, is this it? Maybe this is Sirius. Yeah, there's Sirius. Sirius is the brightest star in the northern skies, so Sirius will be visible during the eclipse. I would mostly stay focused on what's surrounding the sun, though. It's a little bit hard to predict exactly what you'll see because everyone's eyes are different. The appearance of the sky is going to be like twilight, just after sunset and just before sunrise, similar in that texture to the sky. You can also think about it like a dark sky, but with a full moon. That's also a similar brightness that we're working with. So Jupiter and Venus will be visible in the skies. Saturn as well, if you have a good enough horizon. Mars is a maybe. If we click on Mars, it's a magnitude 1.1. It's pretty dim, but if Vega's out, Mars should be out too. So that's something to look for. Saturn is, actually they're pretty similar. So they're saying Saturn will be there. I think Mars might be too. Let's see what else. I think Mercury is out as well. Right there. Mercury is going to be tricky though. It is, yeah, they're saying it's a magnitude 4.8, which is pretty dim. And if we zoom in, we'll find out why. It's because it's this super thin crescent. The inner planets go through phases from Earth's perspective. So you see this very thin crescent for Mercury. That's not going to be bright enough for us, sadly. So Jupiter, Venus, Saturn, maybe Mars will be visible in the sky. You won't see any detail on those, and I wouldn't even bother with telescopes to try and look at them because they're visible throughout our orbit around the sun. So just look at around the eclipse. That's the best method. Now, if we go to Jupiter, we zoom in some here. You see nearby Jupiter, there's this object. Ponsbrook's. 12P Ponsbrook is a comet approaching perihelion on April 21st. That means it's approaching the sun, getting closer and closer to the sun. Oftentimes, that can lead to some flare-ups of these comets. This comet is already technically visible to the eye. It's hovering right now around a magnitude 5. They're expecting it to get around a 4.5. That's not going to be bright enough if it stays at that magnitude to observe during the eclipse. Cameras can pick it up. So if you're taking a camera with you and imaging the eclipse, you might see the comet that way. I'm going to turn the atmosphere off so we can see that a little more clearly. There's the comet in Stellarium. I'll bring it with respect to the sun and Jupiter, in the eclipse rather. So Jupiter, Ponsbrook's, and the sun and moon. If it flares up though, that means it's going to brighten quickly. We don't have much time for that to happen. But if it's going to happen, it often does as it gets closer to the sun at perihelion. So we'll keep our fingers crossed, because that would be quite the sight. If you're already enjoying the total eclipse, you may see a comet in the sky if it flares. This comet does come around once every 70 years or so, so it's a pretty regular comet. And yeah, it'll get close to Earth, I think, in June, early June. So it may even still be visible post-eclipse on the other side of the sun. We'll see. But again, if you have camera gear that you're safely using for the eclipse, and you know you have all the equipment to do that, maybe try and catch Pons Brooks in the sky, because you won't need too much exposure to capture both. Okay, jump back here. We're going to quickly go through the rest of what's out in the sky here, because we're running a little bit over time. But the moon is visible on April 8th in the form of a new moon. Only time that you will see a new moon in the sky. The new moon is when our side of the moon that's always facing us is in darkness. It's nighttime on that side. So it's the only time you can see the presence of the new moon. The lunar cycle goes through, you go through a lunar cycle once every 29.5 days, so just under a month. You can think of about a significant phase of the moon every week. So you start with new moon. A week after that, you get first quarter, which is a half moon in the sky. Week after that, full moon. After that, it's a third quarter, another half moon, and then it goes back to new moon. You can observe that in any way you like: unaided eye, binoculars, telescopes, or cameras. It's bright, but not bright enough to hurt your eyes. When it's near the sun, though, the sun's the problem there. So make sure you do wear solar eclipse glasses. Planets. Yeah, not too many. There's Jupiter. Jupiter is out right now in the sky, but it's setting quickly. If you are up early, Saturn and Mars are up. So in the early morning hours, you can see Saturn and Mars rising in the sky. But as far as nighttime objects, Jupiter is the only one right now. We're going to skip this step because we kind of saw them and how you can navigate around those. Star stuff. We're talking some deep sky objects, things beyond our solar system, but more than just stars. Maybe many stars, like the Orion Nebula, which is M42 in the Messier catalog. This one was taken through our 6-inch refractor telescope at Kopernik, and it's a stellar factory. This is where stars are born in this region of space. The pink and red coloring you see there is ionized hydrogen, and then the bluer colors, that's just starlight reflecting off these nebulous clouds. So, a stellar factory. The next stage of the stellar life cycle is an open star cluster. After you run out of fuel, things start to diffuse and spread out, including the stars. They find their own little locations in space, and they have protodisks that